Okay, so your warm-up today is page 40. There are 8 questions, 3 are true and 5 are false, and we are going to determine which ones are which. So we're going to pause the video here. I'll give you about 5 minutes to decide which are true and which are false. Okay, number 1, you should have said false. There is no property where the argument is added that I can expand with adding. That doesn't work. Number 2 is false. When the argument is multiplied, I can't just make that 7 be the coefficient. I could expand that with adding, but I can't bring the 7 to the front. Number 3 is true. When the argument is divided, we can separate with subtraction. Number 4 is true. When the argument is multiplied, we can separate the logs with addition. Oh no, that's tricky. Oh, they almost got me. See how that's a base 10? These are base 2s. Oh, no, false. The base has to be the same. So their expansion is correct, but the base needs to be 10, so that one's not right. Yikes. 5 is false. When the argument is divided, I can't make 2 logs divided. That makes no sense. This exponent can become the coefficient like this, and the bases are the same. That's true. Just the x's squared, not the whole log. So this is false. Did I get all 3 trues? I got 1, 2. So this one must be true. Let's explain why. Argument is multiplied, so I can separate with addition. The bases are all 10. And technically, they could have kept the absolute value here, but the absolute value of 4 is still 4, which is why we don't need it. Okay, so the word problems in your packet on page 41 are not the greatest. So what we did is we updated it, but you need a handout because it didn't make it in the packet. So everybody should have a green handout. And we are going to go through, let's see, the front and the back. So we got 7 questions. You need your calculator. I got mine. Here we go. A cup of coffee in Fahrenheit is this function, where T is time since it was poured in minutes. Determine the coffee when the temperature when the coffee was served. So that would be when time is 0, when it's originally served. So C of 0 is 90 plus 65e to the negative 0.123 times 0. Here's your calculator part. 90 plus 65. Your E button is next to the 4. I have this 86 calculator here at home, and the buttons are in different spots, so I need a second to find out where E is. There it is. Okay. E to the negative 0.123 times 0. 155 degrees Fahrenheit. So the math that justify your answer is showing the 0 substituted in for T, then you get your value. Determine the temperature after 15 minutes. So that's time. So I want to know C of 15. So we put 15 in for T. If you do second enter, it brings back up what you typed, and then I can just replace my 0 with the 15. And now our temperature's cooled off a little bit to 100, 3 decimal places, 2.272. You have to round that to a 2. So that's 100.272 degrees Fahrenheit. Determine the perfect time to drink your coffee if you want it to be 95 degrees. So I want 95 equal to 90 plus 65e to the negative 0.123 t. So now we have to solve for t. This is going to take more work. So first we have to isolate the exponential. So subtract 90 to the left. And then we're going to divide by 65. So we can do 5 divided by 65 in the calculator, but it's a really long decimal, so I'm just going to leave it as 5 over 65 because I don't want to round too early. So now to solve, the exponential expression is isolated, so I'm going to, because it's a base e, ln both sides. So ln. The benefit of that is the exponent can become the coefficient, and then ln of e is just 1, so I don't need to write times 1. We can just not write it. It doesn't change the value. So we've got ln of 5 over 65. So that's negative 2.56 on and on equals negative 0.123 t. So to isolate t, we're going to divide by negative 0.123. So my answer divided by negative 0.123 is, run out of space, 20.3 decimal places, 853 minutes, because at the top it says minutes is our time. Let's do that again. Now we want to know the perfect time to equal 110 degrees. So I set my whole equation equal to 110. Subtract 90. You can use your calculator for the arithmetic if you like. Divide by 65. And now to get the variable out of the exponent, I'm going to ln both sides. So I get ln of 20 over 65 equals negative 0.123 t. Remember, ln of e is 1. If you're not sure, you can always do that in your calculator just to check. So then I will divide by negative 123. All right, ln of 20 over 65 divided by negative 0.123. So we could drink the coffee in 9.583 minutes. All right, on the back. Mrs. Mohan wants to save for a summer vacation trip. She's going to deposit $1,000 and it pays an interest rate of 9%. So last year in Algebra 2, you learned about, hi.
What wanted you to say?
Okay, I'll be right there. Okay, you learned about,
What is that, Mommy?
I'm making a video for my class tomorrow because I can't be there.
What is that?
This holds my phone. Okay, let me finish the problem, then I'll come do bedtime.
His book's in his bag.
Okay. Okay, so you learned how to write a function where you have your initial value, 1 plus r to the t. This is an equation you have to memorize for your unit test next week. So our initial value is 1,000, 1 plus 0.09 to the t. So if we do 1 plus 0.09, we get 1.09 t. When will her account reach 2,000? So we say 2,000 equals 1,000, 1.09 to the t. Divide both sides by 1,000. And now to get the variable out, you can choose ln or log. It's a personal preference. It doesn't matter. I'll choose log since we used ln before. We're going to log both sides. But now log of 1.09 doesn't disappear. Instead, just the t will become the coefficient. Then we can divide both sides. And it will take her oops. 8.043 years, wow, to save $2,000. All right, we're gonna do that one more time. Now we wanna go to 4,000. So we got 4 equals 1.09 to the t. This time I'll ln, just to show you it doesn't matter. You can pick your personal preference. If it's not a base e, you can choose ln or log, whatever you like best. And we get 16.086 years. Okay, so your homework is page 42, 1 through 4. You can cross off 5 and 6, but I want you to add in 3b. So this is page 42. It's your homework. 1 through 4. Add in 3b. And what I've done for you here, and we'll pause it and keep it up, is I've put which formulas you have to use for each problem. So 1 and 2 is that 1 plus r we just did for Miss Mohan's vacation. 3 is because it's decaying and going down, 1 minus r. And 4, because it's continuously, we use e to the rt. Last year you might have called it the PERT equation, but it's the initial value, e as the base, to the rate times time. All of these r's need to be the percent as a decimal. And all of the answers to these 5 questions will be in Drive, so you can check not only your answer, but also your work.